All right, we are going to do that assignment more with graphing quadratics, looking at 9 through 20. So starting with the first set of problems, 9 through 12. So I'm just going to go ahead and type in the problem. So I hit my y equals button so that I could graph it. I've got 2 times x minus 3 squared minus 1. I'm going to go ahead and hit the graph button so I can see it. Right? And so we're answering some questions about the function. So here it says, where is the function negative? What are the zeros of the function? Where is f of x greater than or equal to 0? And then where is the function increasing? So remember, whenever it says the function, it really means the y values. So where is the y value negative? What are the zeros of the function? That's just another way of saying what are the x-intercept, which is another way of saying where is y equal to 0. So they've asked us where is y less than 0, where is y equal to 0, and then this, where is f of x greater than 0, is another way of saying where is y greater than 0. So they've asked us all the different ways they can ask us. And then this is just a different question altogether. So what I'm going to do is kind of color in the picture where the different answers are. So y is equal to 0 right here and right here. So these two are the answer for number 10. So that's the zeros of the function. That's where the y equals 0. The y value is going to be less than 0 when the outputs are negative, when the y values are negative. So that's going to be right here. So number 9 is going to be when my outputs are negative. Hopefully you can see that right here. Okay, and then my outputs are positive right here. These are positive y values. Positive y values, positive y values. So there's my answers to number 11. Okay, so I just need to figure out how to write all these answers because I can clearly see it. So here, these answers are below the x-axis. This is the x-intercept, and then these are above the x-axis. Okay, so I'll go ahead and find these first. So I'm going to do, for the x-intercepts, I've got second trace, option number 2, the zeros. My first 0 is between 2 and 3. So for left bound, I'm going to type 2. For right bound, I'm going to type 3. 2.293. Okay, and then for the second one, the answer is between 3 and 4. So for my left bound, I'm going to type 3, enter. For my right bound, I'm going to type 4, enter. The guess is always silly, so I'm going to type enter one more time. 3.707. Okay. Okay, so up here I have a left arrow, so that's negative infinity. Up here I have a right arrow, so that's positive infinity. Okay, so for number 9, that was my yellow. So my answer for number 9, where's the function negative, is from 2.293 to 3.707. So lower number 2.293, higher number 3.707. I'm not going to put a bracket on these because a bracket would say that I'm including those numbers as being negative, and 0 is not a negative number. So I'm going to do a parenthesis. So brackets mean the number in your answer, and I should not. Next, I'm going to write my pink answers, and I have 2 of them. So my first pink answer is from negative infinity to 2.293. And then my second pink answer is 3.707 to infinity. Infinity or parenthesis because I can never actually equal infinity. And then for the 2.293 and the 3.707, I have to think about if it should be a bracket or a parenthesis. So when I look, it says greater than or equal to 0. These are numbers that equal 0, and I'm allowed to equal 0, so they should both be brackets, because I can actually equal them. So I put my little stick figure guy. He starts here. And he starts with decreasing. He decreases down to the bottom of this valley, and this valley is at an x value of 3. And then he hits the bottom of the valley, and then he starts increasing. He starts going uphill. And so the word increasing is in between the numbers 3 and infinity. He always gets a parenthesis. The number 3, if I think about the number 3, is he walking uphill at the point that he's standing at the number 3? Well, no, he's not walking uphill. He's kind of in between, so I'm going to put a parenthesis. Okay. All right, let's go ahead and do the next set. So again, we have these same types of questions. So where is the y value positive? What are the x-intercepts of the function? To number 14, they're right here. And then where is the y less than 0? Okay, let me go ahead and color this in. So where is the y less than 0? I'll use yellow. Y is less than 0 over here, where it's below the x-axis. Where is the function positive? So the outputs are positive here. These are all your positive y values. Okay. So this is above the x-axis. Okay, so what I need to do now is go through and graph this so that I can find the actual answers. So negative 1/3 x squared plus 5. And if you want, I'm actually going to type this the way a lot of you guys would have typed it. So negative, and then to get the 1/3, we have alpha y equals 1/3 x squared plus 5. Okay. So we'll go ahead and graph. Okay, zeros of the function. So one of the zeros is over here. It's very close to 4, so it's between 3 and 4. The other one is very close to -4, so it's between -4 and -3. So second trace, number 2, left bound is -4. Right bound is -3. The guess is silly. Okay. And then it's going to have some symmetry, so assuming that the right side is the positive version of this, but we can still do our left bound and right bound. Yep. Okay. All right, so where is the function positive from negative 3.873 to positive 3.873? So brackets or parentheses. Well, the only reason we had brackets up here was because for the positive answer it said greater than or equal to 0. 0 isn't really considered a positive number, it's kind of neutral. And so we're going to do parentheses. Where are we less than 0? So those are the answers over here. So we got negative infinity. Negative infinity to the negative version. Uh, 3.873 infinity. And then this time we are not including 0, so we're doing these chunks without including the number. Okay. What is the end behavior of the function? So we have to say that the left arrow goes down and the right arrow goes down. So as x goes to negative infinity, left arrow. As x goes to positive infinity, that's the right arrow. They both go down. So y goes to negative infinity, y goes to negative infinity. So the left arrow goes down, the right arrow also goes down. Okay, so here we have two functions, f of x and g of x, and we're finding things about them. So f of x is a function that is right side up, because it's positive in the front, it has a vertex at 1, negative 5. So it's right side up and then 1, negative 5. So this is f of x. Okay, so that's the black one. Okay, and then g of x is upside down, and that one has a vertex at positive 3, negative 1, so upside down. Okay, so this one's g of x. Okay. So where does f of x equal g of x? That just means where they intersect. Okay. And when it says where, it's asking for an x value. Where is f of x greater than g of x? So when it says where, that's an x value. Remember when it says f of x and g of x, we could say y and y, and these are not the same y's. It's the y of f of x and the y of g of x. So those we're thinking of the outputs. So what x value tells you that the output of the black line is bigger than the output of the gray line, which for us, since it's a y value, it means where is the black line above the gray line? Where is the black line above the gray line? Where are both functions increasing? Where are they both slanted up to the right? And then we got a transformation question. Okay, so first, where does f of x equal g of x? Where are they intersecting? And this we can answer just by looking at the graph because they intersect at nice points, but we're going to go ahead and do it as though they didn't because I want you guys to know how to do this on a calculator. So we're going to graph it. F of x, x minus 1 squared minus 5, g of x, negative x minus 3 squared minus 1. Okay, so there's the picture. So we're going to do second trace like we always do. That's our menu. And intersection is number 5. So with intersection, you don't have to do anything at first. You just have to have your cursor kind of close to one intersection. So right now we're closer to this one. So all you do is press enter, enter, enter. The questions that it's going to ask are first curve, then second curve, then it's going to ask for the guess, which is always silly, and then we're going to get an answer. So I'm just going to press enter, enter, enter. Gives me this one. So the first answer is 1, -5. So where do they equal each other? Technically, the answer is just 1. X equals 1. So that's the point 1, -5 if you wanted the input and it. But technically, since it just says where, you only really need the X value. And then we're going to do second trace number 5 again. And now we actually have to move the cursor because we want it to be closer to the other intersection. So I'm just going to arrow until I'm closer to the other one. And then we can press enter, enter, enter again. You don't have to be right on it. You just have to be closer to this intersection than the first one. If you're closer to the first one, it'll just keep finding that answer over and over and over again. So enter, 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 and 3, -1. So X equals 3, which is the point 3, -1. Okay. So we found the two places where f of x and g of x are equal to each other, x equals 1 and x equals 3. Where is f of x greater than g of x? And that's just where we're saying f of x is above the gray. So you can see where that happens. The gray stops right here at 3. And then from there, it is above. So right here, when x is here, it's above the gray. And maybe to make that less confusing, I'll do it in pink. And not right here, though. The gray is above the black. Do you see that? The gray is above the black right there. But then also over here, it's definitely above the gray, but also right here, this whole part, it's above the gray. So for all those chunks, you can see that the black is above the gray. The only time the gray is above the black is right here. Did you guys see that gnat in there? That's the beauty of having houseplants. All right, so the black is above the gray. This whole part, obviously this whole part, but also down here, the black is above the gray because the gray is beneath. So we're going to say the black is above the gray from -∞ to an x value of 1. Now we have to think about if this should be a bracket or parenthesis. So can I say the black is above the gray when the 2 points are, when the two graphs are equal to each other? The answer is no, they're equal. So you don't have one that's above the other at that point because they're at the same. So that's going to be, and then here at x equals 3 to infinity. Okay, 3 to infinity. All right. The next question is, when are both functions increasing? So I need to know when the black is increasing. I need to know when the gray is increasing. So let me go ahead and just answer these over here. I'm going to answer them individually first and then kind of say. So here's the black graph. Positive infinity, 1. So the black graph is decreasing and then increasing. So the black graph increases from 1 to infinity. The gray graph walking uphill, walking downhill. the decreasing answer. Increasing answer. So the black graph is increasing from 1 to infinity. Not very much overlap there. This on like, you might be able to see it here. So the gray graph is only for all of their negative numbers, and then 0, 1, 2, and 3. The black graph is increasing from 1 to all its positive numbers. So the only place where they overlap is from 1 to 3. That's it. So they're both increasing here. Right here, they're than that, the black graph is decreasing, or the gray graph is decreasing. So when are both graphs increasing from 1 to 3? Okay. G of x was 1, what would its new equation be? So right now its vertex is at 3, negative 1. If it was shifted to the left 1, its vertex is at 2, negative. So it would be negative x minus 2 squared minus 1.